True Projects. In this video, we are going to explain about the project that is a comparative study of using deep learning algorithms in network intrusion detection. Before getting into the execution, first let us understand what is the project about. So think about how much we rely on computer networks these days for everything from running businesses to staying connected with friends or even handling sensitive information. Now, as much as these networks are backbone for all this, they have also become a hotspot for cyber attacks. And these attacks are not just increasing in number, they are getting smarter and more complex. Traditionally, we have signature based methods in network intrusion detection systems. These are like security guards who have a list of known attacks, that is, troublemakers. If an intruder matches something on the list, the system catches it. Sounds good, right? But here the issue is what happens when a new type of attack shows up or something no one has seen before? So these systems can't recognize it because it has not in the list. Here where anomaly based detection method comes into the picture. It's like spotting anything weird or out of the place. It is great because it can flag completely new type of attacks. Even those 0 day attacks, that is 0 day ones we have heard about. Once here the problem is it is overly sensitive. Imagine every small harmless quick network behavior being flagged as a threat. That's what we call as high false positive rate. We call it as high false positive rate. And to make anomaly detection work well, it need a lot of high quality training data to know what normal looks like, which isn't always easy to get. And with the rise in Internet of Things and cloud-based services, network traffic has exploded. Think about it. Everything from smart home gadgets to healthcare devices and cloud applications are constantly sending and receiving the data. This means the amount of data flowing through network today is massive and more varied than ever before. And analyzing this traditional data, the problem with the traditional intrusion detection systems is that they have to figure out what is normal and what is the potential threat. And it is huge, ever changing sea of the information. It's not like the old days when the network were more predictable and static. Now here we got all sort of protocols and data behaving in ways that can be hard to keep up with. For example, a network might switch between different types of traffic or change its setup in real time, making it harder to identify malicious activity. So the real challenge here is what existing NIDS system are struggling to handle this sheer volume and diversity of data. What we need a smarter and more flexible systems that can keep up with the constant changes, adapt to new type of threats, and still be accurate enough to avoid false alarms. It is about staying one step ahead of malicious actors without overwhelming the system with unnecessary noise. So to overcome with all these issues, in this project, we are using multiple deep learning models to improve how we detect intrusions in networks. Essentially, we are building a system that can tell whether network activity is normal or suspicious. So here we are using 6 different deep learning models, each with its own strengths. And these models include deep neural network that we call as DNN, convolutional neural network that is CNN, recurrent neural network that is RNN, and long short-term memory that is LSTM, and gated recurrent unit that is GRU. And here we have also used a hybrid model that is combining CNN and LSTM into a hybrid model to leverage the best of both the models. And the other part is that here the goal of the system is to handle two main types of tasks. One is binary classification and the other one is hybrid, that is multi-class classification. So coming to this binary class classification, it is just simply deciding whether something is normal or not. And coming to this multi-class classification, here we will be deciding that is we will be identifying specific types of attacks like denial of service attack or a probe attack. And to train and test these models, here we are using NSL KDD dataset, which is a standard dataset used in the field of network intrusion detection. It allows us to evaluate the system's ability to detect different types of malicious activity in the network. And here, the deep learning based approach can handle large volumes of data and adapt to complexities of modern networks. So, by combining different models, the system can detect more sophisticated intrusion patterns that may be missed in simpler approaches. It is designed to be reliable and accurate, offering a more robust solution to the growing challenges of the network security. And to further improve the performance, as an extension, we are incorporating multiple hybrid models. That are two hybrid models, that is CNN by LSTM and CNN GRU. So these hybrid models are all about combining strengths of different individual models to improve prediction accuracy. The idea is that CNN can capture spatial patterns like how data points relate to each other in space, while BILSTM and GRU focuses on temporal patterns, that is, how data points change over time. By combining these, the system is better at recognizing complex patterns in network traffic, improving its ability to detect normal and anomalies. And on top of that, here we have built a Flash-based frontend which makes it easier for users to interact with the system. This frontend comes with an user authentication, so only authorized users can access it, ensuring that the system is secure. So this makes the system not only secure and user-friendly, but also reliable, where usability and security is a key. Moving on to the implementation of the project. To implement this project, we have followed the steps mentioned in the flow of work. So these are the steps followed to implement this project. First, we have imported all the required libraries and packages that are Python libraries and packages for data processing, model building, and evaluation. Then comes exploratory data analysis. So here we have explored NSL-KDT dataset to understand its structures, features, and the types of attack it contains. And then comes data processing. So here we eliminate any duplicate entries to ensure integrity of the data. And then we drop unnecessary or irrelevant columns from the dataset to focus only on the relevant features. Coming to data visualization, so here we have visualized the data to better understand patterns, distributions, and relationship between features, which helped in feature selection and model design. Then comes label encoding. So here the categorical variables in the data set were encoded into numerical values using label encoding to make them suitable for machine learning models. Then comes splitting the data set. So here the data was then split into training and validation sets to ensure that the model could be properly trained and evaluated. Then comes building the model. So here we will be initiating all the deep learning models. Here we will be defining all the layers of deep learning models, that is DNN, CNN, RNN, LSTM, GRU, and the other models that we have built. Then comes training part. So all the initiated models are trained using training data, and they are optimized to detect network intrusions effectively. And they are evaluated using accuracy, precision, recall, and reference code, and they are compared through the graphs of the project. Then we have developed a user-friendly front end using Flask framework. So this allows users to interact the system. This includes registration and login setup using an SQLite database for user management. And in the front end, users they will be able to give input data that is related to network traffic characteristics. And that is pre-processed at the backend. It will be fed with the train model, and then finally outcome will be displayed through the front end predicting the network intrusions. So this is how we have implemented the project. Now moving on to the algorithms used. So here we have implemented, that is we have taken set of algorithms for multi-class and other set of algorithms for binary class classification. So for multi-class we have implemented, that is we have built DNN model, RNN, that is recurrent neural network long short-term memory, hybrid model CNN LSTM, CNN plus by LSTM, and CNN GRU. These two are the extension models. And here additionally, here we have implemented two models, that is gated recurrent unit and convolutional neural network. So these two are the additional models for binary classification. And now to implement this project, we need hardware and software requirements. Coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder that contains source code files. Let's open the code folder of the project. So here in this folder, we have the dataset used in this project, and that dataset is pre-processed, and here we have that file. So this is the pre-processed dataset. So these are the set of features, and here is the attack, that is whether there is an attack or not. So here are the different features. Now let's close this. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. And here in this folder, we have HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here in the app.py file, this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here too are the model files that contain the algorithm information, and that will be loaded into the project code during runtime of the application. And this is the notebook file, which is a Jupyter notebook file, which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the sample file in which we have test cases that we will be using in the front end to detect the in-network intrusions. And this is the sign up file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. It is open. So now give the command cd, give the space, paste the copied path, and now click on enter. So here current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So just wait for a while. App.py file is being compiled. So here, this is the local host and this is the port. So this is the address where application has been hosted. So now copy this local link provided by the Flask framework and paste it into any web browser. I have copied it. Now open any of your web browser of your choice. I prefer Google Chrome, so I'll paste it in that. So paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. We need to get signed up first, so click on sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on sign in. We have entered wrong credentials. Let me enter again. Now click on sign in. We have signed in successfully and we are redirected to prediction page of the project. So here you can see parameters, right? These are the parameters need to be entered based on the given parameters. We will be getting the prediction. So let's understand what are these first. First parameter which we have is the flag. It represents the status or the type of the connection. It indicates whether connection is established normally or if there are any issues such as failed connection attempt. Then we have source bytes that are SRC bytes. These are the number of bytes sent by the source during the session. So this can give an indication of the amount of data transferred from the source to the destination. Then we have destination bytes. So these are the number of bytes sent by the destination, that is the receiving device, during the session. This measures the data flow from the destination to the source. Coming to count, it is the total number of connections made by the same source during the session. This helps to gauge the activity level of a particular source. Then we have error rate. So this is the ratio of connection that resulted in errors during the session. A high error rate, that is high error rate, could indicate suspicious activity such as an attack or misconfiguration. Then we have same SRV rate. It is the percentage of connections made from the same service port by the same source. Higher values may suggest typical behavior, while low values may indicate unusual patterns. Then we have different SRV rate. It is a percentage of connections made to the different services, that is ports, by the same source. A higher value could indicate scanning or probing activity. Then we have destination host SRV count. It is the number of services, that is ports, that is destination host is serving. This can help to assess the complexity of the destination system and its exposure to possible attacks. Then we have destination host same SRV rate. So it is the percentage of connections to the same service port at the destination host. Higher values might indicate normal consistent behavior while lower may suggest irregular access. Then we have destination host different SRV rate. It is the percentage of connections made to different services, that is ports, on the destination host. Similar to different SRV rate, the metric helps to identify unusual access behaviors. Then the last second one is destination host error rate. It is the ratio of errors encountered during connections to the destination host. A higher error rate could suggest potential issues or unusual activity targeting the destination. Then we have destination host SRV error rate. It is the ratio of service errors encountered during connections to the destination host, and this metric helps in understanding the reliability of the services provided by the destination host. So this is all about the parameters. Let us enter them. For that, let's open the sample file. So here are the different test cases that we will be using now. So these are the test cases. These are the test cases. Now let's enter them. So here we have two classes, that is 0 and 1. Let's apply filter to class 0 and let's enter this case. Now click on prediction. So let's enter the value. So here the flag value is 9. Source bytes are 146. Destination bytes are 0. 13 is the count. Server rate is 0. Same SRV rate is 0.08. Different SRV rate is 0.15. Destination host SRV is 1. Destination host same SRV is 0. And then destination host different SRV is 0.06 it is. Sorry, it is just 0.6. And then destination host server rate is 0. And the next value is also 0. Now let's click on predict. So this given input, it will be pre-processed at the backend and then train model will be giving us a prediction. So here we got the prediction. So there is no attack detected. So here you can observe that there is no attack detected. And here multi-class is also showing that there is no attack detected. Now let's try with one more case. Let's apply filter to class 1. Click on OK. So now let's try with this case. Here flag value is 5 and source bytes are 0, destination bytes are 0, count is 123 and seller rate is 1, same SRV rate is 0.05, different SRV rate is 0.07 and destination host, sorry, we have entered correct values only. And then here we have destination host SRV count is 26 and destination host same SRV is 0.1 and then we have destination host different SRV rate is 0.05. Destination host server rate is 1 and the next value is also 1. Now let's click on predict. So this given information, it will be pre-processed at the backend. It will be fed to the train model. Then train model will be giving us a prediction. So here we got that prediction attack is detected and it is abnormal. So your first binary class has been predicted. That means just it will detect whether there is an attack or not. So here in this case, it has been predicted as abnormal. And in the next case where it is multi-class, it will predict which type of attack it is. So here it has been predicted as DDoS attack. So here DDoS attack has been predicted. Initially, in binary case, it is just predicting whether it is normal or abnormal, and then coming to the multi-class, it is specifically identifying which type of attack it is. So now let's check with the one more class. Let's click on prediction again. Let's try with this case. So where flag value is 9, SRC bytes are 8, destination bytes are 0, and 1 is the count. And then we have server rate as 0, SRV rate as 1, and then different SRV rate is 0. 53 is the destination host SRV count, and then 1 is the SRV rate that is of destination host. And then we have 0, that is different SRV rate of destination host. Now the next two values are also 0. Now let's enter them 0. Here we have given all the parameters. Now let's just click on predict. Here we got the prediction that there is an attack detected and that attack type is probe attack. So here in binary class classification, first it is detecting that there is an attack and that attack is probe attack. It is being detected by the multi-class. So in this way, you're supposed to execute the project. Now let's check with the graphs. Click on graph. So here the first graph which we have is the confusion matrix graph. This shows the correlation between variables. So this is the confusion matrix. And here we have graphs for multi-class classification. So these are the graphs of multi-class classification. This is the sample outcome graph. Here on x-axis, we have all the target variables that are being predicted in this project. And on y-axis, we have count. So here this graph represents the count of each target that is being predicted in this project. And here this is accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained for classifying the attacks in multi-class, that is detecting which type of attack it is. And here we have precision score. This is the recall score. This is FN score. And these are of multi-class. And here comes binary class comparison graph. So these are the sample outcome graph. This is the sample outcome graph. Here on x-axis we have target class and on y-axis we have count of each target. Here 0 represents no attack and 1 represents attack. There comes accuracy comparison graph. Here is precision, recall, and FN score. So these are the graphs. Now click on sign out. In this way, just by giving input to the application first, it will predict whether there is an attack or not. If there is an attack, it will detect which type of attack it is. If there is no attack, it will just show that there is no attack, it is normal case. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.